Okay, so thank you very much for joining us today. We're here to, this is part of our monthly webinar series at the Institute of Analytics, where we offer support to data scientists, business analysts, people who would like to join us in our career. It's a wonderful, wonderful career to be in. But we know that the pathway into data analytics is never 100% smooth. And particularly if you're qualified and reading all the hype around data analytics and you're struggling to find a job, it can be a little bit disheartening. So we have this webinar today where Rohan, my colleague, is going to talk you through everything you need to know. Rohan joined us just over a year ago, and he's just been an amazing support on the data science front. He leads up a lot of our hands-on training. He supports a lot with our data engineering track, and I know that this particular talk goes down incredibly well. And if you are interested at the end of this webinar in finding out more about what more we can do to support you, we give away a lot of our content for free at the Institute of Analytics, but of course we do have a special relationship with some people through membership, and we can support you even more through that platform. Right, I will jump off and hand you over to Rohan. Off you go.
All right, thanks for that, Claire. Hi, everyone, and thank you for attending the webinar. This webinar is just going to be on data science careers, entry points, pathways, how to get into it, how to kind of exit the kind of unemployment plateau that people often get when switching sector into data science and data analytics, and also just going over the different specializations that have become more pronounced within data science. There's been a lot of hype around data science in the past few years. I think in 2020 was called the most sexy job in the world, and it still is a very quote unquote sexy, quote unquote high paying job. It's very complex and it requires a high skill set to really progress in. But it's definitely something that you should be interested in, and if you are interested in, it's a good choice for a career, especially if you like problem solving, you like strategy, and you like thinking about problems in a methodical kind of way. I'm first going to introduce myself. As Claire's mentioned, I'm Rohan Whitehead. I've been at the IoA for over a year now. I have an undergraduate degree in politics and philosophy, so not the most orthodox route into computer science and data science. But during COVID, I took a master's degree in data science, whilst the job market was slightly plateauing and I had to decide a career direction for my life. I decided, because I had a strong interest previously in games and strategy games such as chess and poker, and analyzing data sets to improve in those, I thought my skill set would be suited to data science and trying to improve my own performance in those games. My role at the IoA, as Claire's mentioned, is creating and communicating training content, whether that be blogs or webinars or any of our on-site training content. And my interests, as I've said, are just games and playing those games, as well as music and other generic interests that are not really relevant here. So data science as a career has undergone some fairly large market shifts and trend shifts in the past few years, especially post the COVID era. Generally speaking, as the market has become more saturated with applicants, large companies have started requiring a more specialized skill set for you to be employed. And therefore, there's been a bit of a shift now from a generalized skill set to a specialized skill set. What this means is the general base level fundamental skills, while still important, will not always get you a job anymore. A specialized skill set such as machine learning, cloud computing, data engineering, data warehousing is more required to obtain roles in the market. Of course, this mostly applies to large companies. Small companies that don't have a proper data architecture will still be looking for generalized skill sets and generalized data analysts and data scientists, as they cannot afford to hire multiple personnel to fit every niche role. So as I said, big tech is starting to prefer machine learning, AI, and business intelligence specifically. They also are looking for cloud engineers and data engineers, as there are exponentially more amount of data and the amount of more essentially data warehouses and data sets they need to maintain. But the most common specializations are definitely currently just machine learning engineers, machine learning operations, and then cloud engineers. Those are kind of the two branches that people generally branch off in and hear about first. That's why they are the two kind of most pushed modules. If you take a master's in data science, most masters in data science will try and push machine learning, cloud engineering on their students very hard. Specialized skill sets allow companies to kind of leverage your skills specifically to meet their niche needs. And your skill sets is much more easy for companies to leverage to their specific wants when it is specialized. A specialized skill set does not mean you cannot do what a general data analyst can. Usually the expectation is you can do everything a data analyst or a basic data scientist can and more. So you usually learn to do what a data analyst can do and then choose to specialize. You don't specialize from the very beginning because then you miss core fundamentals of data analytics. In the past year, wage growth has slowed generally in just amongst all jobs. However, data scientists still see a steady growth in salary and a very competitive growth in salaries compared to average wages, as we'll see further in the presentation. More specific sectors, nearly every specific sector now requires data expertise and data professionals within their companies. Sectors such as healthcare, fashion, gaming, sports all require experts to handle their data and to create insights or utilize the data to benefit the companies and benefit the sectors. And therefore, domain knowledge is becoming increasingly more valuable. By domain knowledge, I just mean sector-specific knowledge. Any knowledge that you have that may be useful, and if you have a strong interest in a specific sector, whether it be healthcare, whether it be sports, you will probably have a strong advantage compared to the general applicants for getting a data job in that sector. And you should bear that in mind. If you have a very, very strong sports background, you've done sports analytics, you take part in stuff like Fantasy Premier League or Fantasy IPL, and you really like looking into those kind of stats, you will inherently have an advantage against other people when applying for, say, a sports analyst position or a data scientist position in a sports analyst company or even sports journalism. And finally, post-COVID, during COVID, work from home became a big thing, and it's a fairly cost-efficient option for companies, especially in data science and tech roles, where people do not benefit hugely from coming into work compared to more communicative roles. Of course, data scientists and data analysts do have a fair amount of communication in their job. They need to communicate their findings to stakeholders and essentially decide company direction and allow other people and higher up to decide company direction based on their insights. However, most of their work can be cost efficient and done from home and through video calls. Therefore, you should expect most careers in data science for the time being to maintain as in a hybrid model. Generally, the roles I see require 1 day a week in office. That day will generally be a Scrum day if they're working through an agile methodology where the whole team will all come and do stand up and discuss about the week on one specific day. So as I say, there's loads of specializations now in the data science job market. It's not just data analysts, data scientists. So we'll just go through some of the specializations for a few minutes. I didn't mention at the start, I expect this webinar to take about 45 to 60 minutes. There will be time for a few questions at the end, depending on how fast to get through the content. But I expect to be speaking until about at least 11:50 BST. So on first, when I show this to especially students, this can look a bit overwhelming. There's so many specializations now in the job market that people don't really know where to start or what to learn. This isn't actually as overwhelming as it initially looks. As I've said before, only bigger companies with the required capital and the already established data infrastructure and architecture can seek specialized roles and niche roles such as machine learning engineer, BI developer, etc., or even NLP engineer. Smaller companies or companies with reduced capital, or just companies that don't want to spend that much money, even if they have it, will not be looking for these specializations in general. Of course, some small companies, especially tech startups, will require specific, say, AI engineers or AI integration engineers to integrate new technology into their products if that is a selling point. But general SMEs and companies that, as I say, don't have the capital and infrastructure will still be looking for data analysts and data scientists. The only difference this really makes is it drops the lowest starting salary for data analysts and data scientists. The high end pay for all roles is still very high, but the starting point for data analysts and data scientists is slightly lower compared to data engineers and machine learning engineers. But on the flip side, every specialization needs to have the core skills of a data analyst, and most companies will want you to have the core skills of a data scientist, whatever you do. There's one exception, maybe two exceptions, such as a data steward, which more thinks about the ethical and auditing side of AI and data, whether you're following governmental policy, whether you're following legislative policy. So it does not need to have as much hands-on experience and practical experience with data science. And then there's also a business intelligence. Well, anyone working in business intelligence does not necessarily need to have in-depth Python and machine learning knowledge. They just need to understand the Python fundamentals and be able to apply essentially spreadsheet analysis and data analysis in a more dashboard, Tableau, Power BI sense. So as I say, I strongly recommend everyone focus on becoming a data analyst before they focus on any other specialization. But you don't need to have a full in-depth data scientist skill set to get every job on the market. There are other jobs available. However, obviously personally, I think data science is very interesting, and stuff like machine learning, although it has been very hyped and it is a lot more studious and a lot harder than media makes it look, especially on the mathematical side, it is still a very interesting subject, and what you can do with it, you pretty much do anything with it when you are comfortable enough with it. A lot of these job roles, if you look on the job market, you won't see some of these job roles, mainly because most companies don't need one, or they're very, very specialized, and therefore they're not actually posted on job markets. You get the roles through networking and through career progression. Stuff like data stewardship is very rare. You see that actually on a jobs board. You usually get that through career progression within a company or through networking, because generally that's a reputationally based role. So it's not at all entry level. And then there's stuff like prompt engineers. Prompt engineering is still important, but generally it's being integrated into the general skill set of a data scientist, or just within teams at companies as more and more functions essentially start to use generative AI tools as part of their day-to-day work. So some of these roles, because they're quite new now, especially AI-focused roles, will become more so skills that are integrated back into the base roles that you see, such as data scientist and machine learning engineer. So I'm just going to go through some of the key roles that is on the job market. I know a lot of you will be comfortable with this, but I just need to make sure everyone knows what a data scientist does compared to a data analyst, etc., etc. So very quickly, a data scientist is a role that is mostly focused on extracting insights from your data and informing business decisions, whether that be to stakeholders or any higher ups, or even consumers. Their main responsibility is using machine learning or standard analytical techniques, generally within Python or R, sometimes Julia or Mojo if you're using newer languages, to analyze large data sets to identify trends within those data sets and patterns within those data sets. If they verge more on the machine learning side, or if they have large data sets to analyze, they will often use machine learning techniques and process their cleaned and structured data through machine learning modules to automate their system and automate their job. Visualization is also important. A lot of people sleep on data visualization skills. They think it's just a part of a thing that you learn when you learn machine learning. It is not at all. Data visualization is very important for data scientists, as they need to be able to communicate their insights, and their communications has helped and bolsters hugely if they have a visualization they can point to that shows essentially the output of their data and analysis cleanly. A clean visualization can communicate very quickly what words may take a few minutes or even days to communicate, or a long document. So data visualization is very important for the data scientist. And then also just communication skills in general. A data scientist, along with all data roles, generally speaking, except the very specialized technical roles, need to know how to communicate their finding. There's a misinterpretation of data science and tech in general that people employed are very secluded from the functions of the rest of the business. But in a sense, a data scientist is a business role that decides business direction based on data. So they don't work completely in silos. Some companies, because AI and machine learning is still relatively new, used to have their tech teams in a complete silo. So they are in the process of integrating that into the business. But if you enter a new job or a big organization now, you won't be working in a silo with the rest of your tech team with no communication with the business side. Expected skills, this is kind of the base skills. If you have taken a master's or undergrad in data science, these are the skills you will learn and you will be expected to know fairly well for any job application. This is statistical analytics, just knowing basic stats, linear algebra, and then basic computational modeling, how computers work, what computational complexity is. I know asking about computational complexity it's a very niche thing that students mostly learn during their degrees, but it's very worth looking up, as a lot of interviewers in the application process will ask the technical question of showing you an algorithm and asking you what the computational complexity is. So it's very important you understand those basic fundamentals. Language-wise, Python, R, SQL, and then if companies are upscaling, maybe Scala, are all very important. And then there are new languages coming out that you may be expected to learn. Julia is fairly new and is a mathematical language that is essentially like Python, but more niche, but faster. And then there's also very new languages such as Rust and such as Mojo, which are extremely niche functional languages for machine learning and data engineering. As I've said, you need to be skilled in data visualization. Tableau, Power BI are the two main market leaders right now. These are dashboard creators used to essentially visualize your data and insights. Power BI is a lot more affordable and therefore a fair bit more common within individuals and is the easiest one to learn. Tableau have recently hiked their price massively. And although they are very popular amongst big companies because they do deals that allow like multiple licensing, if you're looking to learn something individually, I'd recommend probably leaning towards Power BI just because smaller companies and more companies are more likely to be using that over Tableau. And then understanding your machine learning techniques, of course. You don't need to be an in-depth machine learning engineer. You don't need to fully understand deep learning, reinforcement learning, and all unsupervised techniques. But you need to know, generally speaking, how machine learning works and how to implement it into your process and pipelines. And it's very good to be able to be the one to suggest to businesses, hey, this is how we can speed up our processes, or hey, this is how we can better understand our consumer base and their behavior. You want to be able to be the one making the actionable insights, actionable suggestions, as this will boost your career progression. And then, of course, a strong problem-solving skills. This is inherent within the expected skills through all data and tech roles. Now we're going on to data steward. I mentioned this quickly earlier. It's essentially about data asset management, data quality management, and data policy enforcement, with emphasis on data policy enforcement. With the rise of AI recently, the IoA is especially working on something called AI auditing, the ability to prove that you understand the processes that your company is going through when they use AI, they implement AI, they build models, and they extract user data. This goes all under data policy enforcement and following regulations, and this would be the responsibility of a data steward. It's a communication-based role. It's all about knowledge, theoretical knowledge, and understanding what companies can and can't do and what they should be doing and how they have to comply to the guidelines of their jurisdictions. The expected skills is just a large knowledge base. so data government practices. You still need to have experience with data quality tools, mostly talent currently, and you need to understand the data laws, security laws, and be able to mitigate risks and communicate, especially within times of crisis or within times of panic when things go wrong. It will be up to you to essentially mitigate any losses or any kind of big miscommunication errors during those times. Going on now, this is the more mentioned one, machine learning engineer. This is just it's as it sounds, a specialization within machine learning that data scientists sometimes take to boost their career progression, or if big companies are working on projects implementing AI into their pipeline or building their own products, we will often need machine learning engineers, or now multiple machine learning engineers. This used to be quite a niche role, say 5 years ago, where companies would only need one or two, but now they're employed by masses, and they're very common on the job market postings. A lot of people join companies as data scientists, then progress naturally onto being a machine learning engineer. Sometimes their job title doesn't even change from data scientist; they just become a machine learning engineer because the company starts needing machine learning practices. But the responsibilities are as you would expect. It's just an understanding of deep machine learning and being able to implement machine learning techniques into your processes and into the company's pipeline, or implement it in products to better suit the product's needs or understand consumer preferences and algorithms. The expected skills, the most common machine learning frameworks still are PyTorch and TensorFlow. TensorFlow is significantly more widespread currently, and at an academic level, you will generally learn TensorFlow before anything else for machine learning, especially for deep learning and the creation of neural networks. Of course, you need to do everything that a data scientist can. You need to know Python, R, sometimes Java, depending on the company, and then there's sometimes the newer languages like Julian Mojo, just to speed up your processes. You need a deep understanding of deep learning. You need to know basically all the textbook understandings. Even if your company doesn't use every form of machine learning, whether it be supervised, unsupervised, or NLP, you need to understand how it can be integrated into your processes. And then you need a kind of partial understanding of big data tools such as Spark, Apache Spark, and Hadoop. These help with processing real-time data, which is essentially it's essential for maintenance. It's essential for product maintenance. One side of the job is building products or building algorithms, but the other side is maintaining them and handling real-time data. And then with this, there's CI/CD tools, Git, version control tools, and the knowledge of cloud computing. You don't need to know how to do cloud computing, but you need to know how it interacts with the models and pipelines that you build. And then finally, I think there's data engineer. I think we have cloud engineer after this, but I think I'll probably skip that one. Data engineer is all about handling data, handling how it's stored, data storing, handling data lakehouses sometimes, and then preparing it for analysis. It focuses more on the infrastructure side and the architecture side. It ensures that companies have a proper data architecture. I said earlier that companies that don't have a proper data architecture cannot really hire niche specializations because their data is not prepared properly. All companies need a data scientist and a data engineer to allow them to specialize and kind of leverage different skill sets, because a machine learning engineer is going to have a really hard time using company data, or going to have a lot of redundant work on their plate, such as data cleaning, if there's no data engineer and data scientist to prepare, store, and kind of extrapolate from the data before the machine learning engineer does their role. Responsibilities generally include designing and constructing highly scalable management systems or relational databases. They need to set up processes for data modeling and mining and production. And also they need to just be able to implement general systems for large-scale data analytics and reporting, and implement cloud computing models and cloud computing architectures to allow for data to be essentially transferable within a company's data architecture. Expected skills are a bit different to the usual expected skills. Although they're mostly touched on within academic degrees, you won't always have touched on all of these, such as NoSQL. Sometimes it's skipped over. It shouldn't be, but it sometimes is. And it's a bit more niche for people learning data analytics in their own time. Of course, we still need to know Python and Scala. Scala is very important for a data engineer or any equivalent. And it's very, very important we know how to use Hadoop preferably, and definitely Apache Spark. I think Apache Spark is becoming the industry leader now with using real-time data. And it is generally, when you look at job postings, the skill set that is asked for the most. Cloud services, apart from being a cloud engineer, this is probably the role that most requires knowledge and implementation of cloud services. AW using Amazon web servers, Azure, or Google Cloud Platform, knowing how to use it and knowing how to integrate it into your own services is very important. And then knowing how to understand data warehousing solutions and tools such as Snowflake or Databricks is, of course, very important. I'm not going to go over this fully, but a cloud engineer does what the name suggests. It essentially manages the cloud and the VPN and cloud infrastructure side of things. Cloud computing is sometimes often very outsourced. It's not always hybrid or in company. Sometimes cloud computing for a company will be fully outsourced to, say, Amazon or an independent storage location, and therefore that company that is outsourcing won't really need their own cloud engineer. I mean, they may outsource their cloud engineers elsewhere as well, but this is a listing you'll see at a reduced rate on the job market, which is fine because generally there are a significantly reduced amount of cloud engineers compared to machine learning engineers just because of how niche the skill set is. The module is generally offered at an academic level. However, it's generally one module, and although it gives you a very solid footing, there will generally be a lot more tools you need to learn to be employed within this field. It is a very niche field. Because it's a very niche field, if you do choose to learn it, it can be very fulfilling, and it can boost, if you do become proficient, it can boost your employment chances significantly compared to a general data analyst, just because you will have a lot less competition. However, it's very hard just because of how removed the skill set is and the different tools are from the general data scientist toolkit. Tools include CloudFormation, terraforming, CI/CD skills is obviously very important, and then using GitHub Actions and Jenkins will be needed for cloud computing. Stuff like Bash and PowerShell, which isn't used too much by generic data scientists, will also be very important for a cloud engineer. You can take independent qualifications in cloud computing. You can get certification from AWS or from Google Cloud Platform, which can help boost your employability within the areas. And this is a route that many people do take. So now the fun part, salaries. This is really the part that initially lures people into data science. A lot of people kind of get a bit too lured in by the salary before really understanding what data science entails. That's why I go through the jobs always before I touch on the salaries. But the salaries are good. And as we can see, this is all the data except one is taken from Reed, taken from the same page. That data was collected at the same time. The data scientist average in the UK is 67,000. This is close to double the average salary, generally speaking. All this data is April 2024. The data scientist average is so much more than the data analyst average, just because it is generally SMEs when they employ, so companies with lower capital, when they employ someone for the data scientist role, they will be employing for the job posting of data analyst because they need the broader skill set, and they are mostly focused on the more fundamental skill set. Data analyst has a significantly lower entry point salary level, so you can get data analyst roles at around 30,000 or even 28,000 out of London. For those who aren't in the UK, you'll just have to generalize this to your own currency. But compared to the data scientists that have a general entry point of about 40,000 into the market. But both roles can scale up the same way to very high salaries from 80 to 100,000 with experience. And then machine learning engineers, they have the same average salary as a data scientist, but they have their entry point salary is much, much higher. It's about 50 to 55,000. This is because you don't really if you can be a machine learning engineer, you can also be a data scientist and data analyst, generally speaking, but it's not the other way around. There are loads of data analysts that just don't have the skill set to be a machine learning engineer. So the assumed skill set and the assumed proficiency boosts the starting salary and therefore the average salary. And then, of course, the same goes for cloud engineers. There's a lot less of these roles on the market, however. And then at the bottom, just from Forbes, we can see the UK average salary. So even for all of these roles, they're all still very good roles for salary and very good roles for career progression. A lot of companies now, the norm is that to employ at a low salary but promise fast progression within a company. This is for companies because companies are now very much so valuing loyalty to the company over just skills. Recently, there's been a trend upwards in a lot of people in data science, essentially company hopping, essentially staying at companies for very short periods of time and then hopping to better companies and better roles. So to mitigate this, some companies now are lowering the entry pay, but heightening career progression opportunities and then opportunities for your pay to increase as you stay in the company, which makes sense, but of course, for people entering the job force, it can be a bit annoying. This is just the US figures from, I believe, last year for the US salaries. It's worth noting that salaries in the US are skewed for cost of living, and for just the currency being worth a bit less than the Great British Pound. So the salary figures will look a lot larger than they are in the UK, but cost of living is a lot larger as well. Here we can kind of see an example of the data analyst having a lower entry points than all of the other roles, while still going quite high up. You will see that the data analyst caps a bit lower at 108 compared to nearly 200 for the rest. This will generally be because anyone progressing further as a data analyst will specialize elsewhere. It is not because there is not the understanding that if you become a data analyst, that's the most you can earn ever. You need to understand that there is progression within the workplace, and as you specialize, your role title will change. The data analyst is still a great place to start and has the most accessible skill sets. There's also data steward. It's a more non-technical communicative skill set. So it will have a kind of lower salary. It's more for people who really care and understand the legislative landscape. So you need to have like that real passion to become a data steward. You need to really care about how data is used. And then obviously at the bottom, the data science manager and managerial roles. These will be more gatekept by years of experience. So you shouldn't really be considering managerial salaries when you're entering the job force or when you're thinking about specializations. So as I said, years of experience do matter. Entry points will be lower initially, and then you will progress very fast. This is just a graph essentially generalizing over years of experience in the US sense. Nowadays, if you're extremely good at a specialization, if you work very hard at it, coming out of university or coming out of continuous learning individually, you can power through your salary. It's about how well companies can leverage your skill set. So if you're an extremely good cloud engineer and it's your first job, you may start low, but you will be able to push your own skill sets. And as long as you can make clear to any company that you can do what you can do, and it benefits the company and no one else in the company can do what you can do, there's no reason why you can't bypass this year structure and get better pay faster. It's all about how you communicate your skill set to your company and how well you can show what you can do. Not just know what you can do, but a lot of people have problems showing their skill sets to a company and showing their utility. So I mentioned continuous learning. This is obviously very important. The number of people who have to upskill or reskill by 2030 is 94%, according to the Chartered Management Institute data. And then obviously upskilling obviously increases productivity within the workplace. Most companies will expect you to continuously learn as you work. Companies sometimes use an agile methodology, which is a kind of structure for work, a week-to-week structure for work. It's very fluid. And within that time, there will be study periods, paired programming periods where you program with one other partner, and also academic reviews if you're working, especially in machine learning and deep tech, where they review academic papers and actively learn as part of the job. If you're looking to progress from, say, a data analyst role or even enter the market as a data analyst, you will need to learn the requirements to progress in your own time. You will need to learn in-depth machine learning. You will need to learn cloud computing or data architecture and engineering in your own time. You'll have to use tools such as tools that IoA offers such as our data camp partnership or our on-site teachings to better understand how what you want to do works and to better understand the tools for those specific jobs. Continuous learning, I assume if you are in data science or data analyst, you enjoy it, you are properly motivated by it, and you like getting better at it. So continuous learning should not be a chore, it should just be a generic and very intuitive pathway to increasing your salary and your success, or your productivity. I've said this a few times now, but I need to really drill this in, that before you look at specializing, before you look at becoming a cloud engineer or a machine learning engineer, make sure you can be a data analyst. This is especially pertinent to people who have just graduated. I find a lot of people who have just graduated and students who have just graduated start to try and specialize far too soon and therefore miss out on the opportunity to apply for data analyst jobs whilst they continuously learn. If you try to learn cloud computing before you are fully confident in SQL and data visualization and Power BI, you will not meet the requirements for the entry-level data analyst and data scientist jobs, and you will essentially be wasting time in a plateau whilst learning, but not actually getting any employment or getting any years of experience. So I strongly recommend you make sure you can be a data analyst or a data scientist before you try to be a cloud engineer or a data engineer. You will also find in your learnings of especially cloud engineering, if you don't have proper in-depth knowledge of Python or computer architectures, that you will have to go back and learn the fundamentals and then continue to specialize. And this will just be an annoying back and forth. Whereas if you have properly learned the fundamentals beforehand, you will be able to fluidly learn the specialization topic. So the stuff on the left is stuff I would ensure you are confident in, and you should make sure you are confident in first. The IoA offers tools and content on all of these things. We offer content on both Tableau and Power BI, as well as we are now making a lot of new content on machine learning theory and communication to go on top of the content we already own. It's good to be familiar with R and Scalar. R is a statistical language, and Scalar is good for scalable data and real-time processing. And even if you are just a data analyst, it's very good that you are aware of basic machine learning processes such as regression, clustering, random forests, even up to basic machine learning and deep learning such as neural networks. You should be able to understand how they work, at least from a theoretical knowledge. You don't need to know how to implement them by heart. And a lot of your role will be looking up how to do things online. People realize fairly fast that working in data science isn't about knowing how to do everything off the top of your head. Of course, some processes become muscle memory, but a lot of it is knowing what you need to do and knowing how to interpret online resources to implement what you need to do and to learn what you need to do fast. Becoming a data scientist and progressing in data science is about compounding your knowledge and using compounded knowledge to be able to learn more and essentially be more efficient with implementing new technologies. No one is expecting you to know every Python library off the top of your head, obviously. They're just expecting you to know, for example, what library to look for, what command to look for, so you can complete and build your pipelines and your projects very fast. So, according to the US Bureau of Labor Statistics, these are the tools that are in demand this year. Cybersecurity tools are up about 42%. Data, as data becomes more and more exponential, there's more and more data in the world. The risks that companies face against data breaches and cybersecurity threats rises exponentially too, and the amount of salary and reputational damage that they face if there is a data breach increases as well. So, although cybersecurity is a bit removed from the data science career path, it's generally a very owned career path with very little crossover, just because cryptography has very little crossover with the fundamentals of data science, etc. It's still a tool that's in high demand this year. Image processing and visual processing, forecasting, PyTorch software with real-time data, and then tools such as data warehousing and Apache Kafka also are in more demand this year. But generally speaking, you don't need to take this slide to heart, really. There's an example of the increase in demand in tools. I see someone's asked a question. Okay, what does CPD mean in this context? CPD is career professional development. It's essentially just progressing in your career and being able to have the knowledge to progress in your career. I hope that answers that question. I will have a short Q&A session time at the end. Just checking what time we are on. Okay, we're on 42. Okay. So a lot of people now, there's the question of generative AI. It went over its massive hype cycle last year with people booming in its use, the development and democratization of ChatGPT 3, which went on to 3.5, and now people, I believe, can pay for GPT-4 for online searching and implementation into their work processes. It's not a deal breaker or a deal maker when it comes to applying for jobs. It is, of course, useful for your own processes to be able to leverage AI tools like ChatGPT and Midjourney for images for content creation, but you should not rely on it and you should not overcommit resources and time to get very good with generative AI tools. It's important to know how to prompt engineer if you think your job has a lot of content creation in it. So it's important to, or if you're working for companies implementing LLMs into their systems. But for the most case, if you're learning data analyst tools or data scientist requirements, essentially, or even cloud engineering or machine learning engineering, you shouldn't overcommit resources to generative AI. As I mentioned briefly before, the IoA is working on an AI auditing certification, where you can prove that you fully understand the theory, the implementation, the practice of your company when it comes to AI and machine learning and what is happening with your data. And this is the niche that will become more and more important as companies face reputational risk if they do not have a full documented understanding of their own processes when it comes to new technology. So a theoretical understanding of AI, LLMs, how they integrate with data, and also how machine learning uses company data and what it can and can't and shouldn't do, understanding ethical issues such as bias, will all become very important when it comes to generative AI and standard AI knowledge. However, as I've said for now 4 times, you don't need to overcommit your resources. I know it's fun to use and I know it can make your job quicker, but also it can't be a crutch we rely on. We need to have oversight over everything an AI model produces. We need to have the human element to be able to communicate to our company-specific resources. With a really great prompt, you can make the tone of a generative AI text model change, but you will still need to add your own personalizations to that output to make it really applicable to your business's use case. General trends in data science, these are always good to know. You should always know what is happening in the sector. It's really useful on especially interviews when people ask you why you got into data science or what you currently find interesting in data science. Interactive AI, we have a webinar recording for the general trends in data science that we did in January on our website. But generally, we think tool-to-tool communication, interactive AI, essentially AI tools communicating with each other. If you ever get a new Apple phone, an updated Apple phone, the way you can just hover it over your old Apple phone and all the data transfers automatically without a human element in the middle. Generally speaking, in the past, pipelines have become human interaction, AI interaction, human interaction, AI interaction. But now we see more and more humans being only at the start and end of processes. They're inputting the first action and then getting the results at the end of the pipeline. This is interactive AI, and it's becoming more and more widespread as companies look to become more and more efficient with their processes. Also, because of the Internet of Things and the expansion of networks, edge computing benefits greatly from interactive AI because it means there needs to be less human elements in the middle of networks, slowing down processes. Open source software. This is more about the rise of the security risk of open source software, and this will become a talking issue as more and more data breaches happen. Now, as well as individual actors, there are sometimes state actors trying to pose security risks to especially Western nations. And these breaches can cost companies millions and millions of pounds and lose a lot of reputation. So the question of whether places like GitHub, places like libraries like TensorFlow that are fully open source should have tighter regulations, and whether fully open source software is a viable strategy for companies developing tools moving forward is something that is a discussion point. Data adoption is very general. All companies now in different sectors are adopting data science techniques, and are looking to employ data analysts. This should be exciting news. This should be exciting for people looking to enter the market. There was a Oxford paper, I think, a few years ago about the future of employment, and this just states it's a really good read. I know the image is very small, but it was by Carl Benedict Frey and Michael Osborne. It's a good read about the importance of data in the market and the importance of machine learning tools in the market. They did one 10 years ago, but they way understated the need for data in that, so they made a new version recently. So it's interesting to see how perceptions of data are changing and how the need is increasing and increasing. And finally, data and AI is a regulated industry. Last year, we saw the EU AI Act that's been passed now in the Parliament. And we'll see the implementation of more and more regulations on AI and data relating to AI use as the years progress and more companies implement proper AI processes into their products. Currently, we're still trying to lay out the framework of how best on an international level to regulate the industry and regulate AI. The world is quite fractured politically right now, and there are many different bodies with different interests. So it'll be a long while until we get any form of international framework. It was hard enough getting the EU AI Act to pass through that one block. So if you consider how to manage different countries' expectations and different needs and competitive advantages to create more universal frameworks and laws, is going to be very difficult, especially with for example, US-China divides and any conflicts ongoing that will split nations and split interests. I know this is quite a dense slide. This slide is more so about how to avoid the plateau. When people become unemployed or people just graduate, there's a plateau that they sometimes reach, which is basically a period of time where they're specializing, but they don't know how to enter the workforce. They feel like they can do things, but they don't know how to show their skills. As I've said before, continuous skill development is essential and is vital that you continuously learn and learn. Ways to show your skills rather than just know your skills, so be employable visually, is to have personal projects, make portfolio and online websites, maybe make your own GitHub and make a personal project using your coding skills, using the skills you are learning that you could upload onto GitHub and link to or reference to on your portfolio or on applications. As I said, continuous learning is also very important. And then one thing people don't do enough, and then they find is a real stumbling block or a hit to confidence, is interview prep and coding challenges. Uh, Machine learning and data science and data analytics interviews can be technical, they can be practical. Generally, after you have your screening interview and your next interview, you will be set a coding challenge or a project. For data analysis, this is generally just going to be spreadsheets analysis and creating a dashboard and communicating your insights on a call. But for data science and machine learning, these can be practical coding challenges. Many of you may have seen videos of people doing Google coding interviews where they're handed lots of algorithmic questions and they need to solve it in real time with someone watching your screen on the other end. There are websites such as LeetCode and Code Wars that allow you to practice real-time problems and solving algorithms, solving problems, fixing code. And this is essentially preparation for interview challenges and application stages. It's also quite fun and it can be quite competitive in nature if people like that type of thing. Also, make sure your LinkedIn is up to date and you have your CV up to date. Make sure you are putting the skills that you can do and the skills that you learn on your LinkedIn profile. Because there are a lot of times the data analysts and people hiring will look at your profile. It's not always you going to them. Sometimes it's them coming to you. So you want your visibility to be as good as possible. I have a friend who recently he spent 4 months whilst he was working on the professional data analyst certificate in DataCamp, which the IoA has a partnership with. Just if you have an IoA membership, you'll get DataCamp membership for free. And he started from no knowledge in data analytics whatsoever. And within 4 months, it's allowed him to do post-interview tests, which include a spreadsheet analysis and dashboard creation. And he now has a risk analyst job at a large insurance company. This is just one example of just the timeline, and if you really put effort into it, how quickly you can convert into a proper job in data analytics. Of course, a lot of it is luck, though. There's a lot of luck, as I'm sure you guys all know, with job applications. You need to be opportunistic and situationally sometimes quite lucky. But as you increase your sample size of applications, you should find in the long run a job for you. Just 2 more slides. Just what's happening in data science. It's the use case of data science in the world. I'll go through fairly fast. There's AstraZeneca, the clinical trials. We use data science essentially to process and reduce the trial durations by analyzing clinical data. This was really important during COVID-19 when we were generating vaccines. So this enhances the speed of development of new medicines as well as the patient care strategies for pharmaceuticals. The Amazon data science team uses data science to personalize the shopping experience. It supports product recommendations, so people are recommended products that are more suited to them, as well. And this kind of generates increased sales as well as increased customer satisfaction, as the algorithm essentially allows them to not waste time scrolling through items that they do not need. The same kind of thing works with ads. People find it a bit scary that their data is processed into cookies and then ads are targeted to their needs. Sometimes, I know sometimes people have a conversation about a certain holiday or destination and then they get an ad on YouTube about that destination. Generally speaking, this is the algorithm being very advanced and predicting what you want to see. This is not the machine always just listening to you. That happens actually very rarely. UPS, the delivery company in the UK, have their own logistical optimization software called Orion, and they use this software to reduce costs and improve delivery efficiency by analyzing routes for fuel usage, distance, and delivery time. So this is a way that logistics can use data science. And then there's also weather forecasting to predict weather and natural disaster risks. We use Internet of Things devices and satellite imagery to collect environmental data, then process it through machine learning models. And then finally, how to stay up to date. This is the final slide. I know I've been talking a lot. I'm sorry for that. staying up to date is really important, as I've said, just being able to talk about data science and keep your interest fresh and keep knowing what's happening in the world. You don't want to be asked in an interview, for example, what you think about the EU AI Act, and you have been stumped and knowing nothing about the EU AI Act. So blogs, we make our own blogs at the IoA. You can also find blogs on LinkedIn, webinars like the ones we do now. News websites, data specific, AI business, and towards data science are the ones I use the most. And then you can get academic publications. I particularly enjoy the tech reviews. They're really good with finding out what's happening in the world. I have one next to me that I'm going through right now, and it really teaches you how to speak about data science quite well. I'm going to leave this slide open. We do have a partnership with DataCamp, and this slide just very briefly talks about everything we offer as the IoA. I recommend you visit our website if you're interested in our offering or want the free access to DataCamp, which has an on-site development environment, no software downloads, or our own context and leadership communication and data science. We have monthly webinars coming up every month on the third Thursday of every month. And we're in the process of making our own jobs board, as well as DataCamp having their own CV upload and jobs board function to attain jobs. I know I have overrun a little bit, so sorry about that. If you have any questions, feel free to ask them in the Q&A chat in the above. If not, I'll pass over to Claire to kind of outro this webinar.
Thank you, Rohan. That was fantastic. That was very thorough. I know one of the challenges of our field is that it is such a vast field. We have so many roles within it. So I'm sure all of you've managed to find something in that list. We're happy to stay on and take a few questions. We do have one question open, and I think, Rohan, I think you've already answered it. Does the IoA provide this kind of support? And, yes, of course, this is what we're here for. Yeah, and I think Rohan has just gone through some of the support we can offer. If you see something that he mentioned that's not on your skill set, something that maybe is licensed, you're busy doing your R and your Python, you might not have bothered with things like Tableau. You can just have a little play with that within our membership platform. Yeah, thank you, Rohan. That was absolutely excellent. Let me just check to see if we have any more questions come in. Do we do mentoring? No, we don't. We work internationally and we haven't found a way to safely and securely bring together safeguarding when we don't have eyes on what's happening with our platform. So I'm afraid we don't offer mentoring. If you are looking for a mentor, I think one of the things I would strongly recommend for all of you is to really value the skills that you're bringing. I speak to a lot of employers and I know they are waiting for people to come with new sets of skills. And they're looking for you. It's just a case of bringing you both together. If you're looking for a mentor, I suggest you start with your personal network or just reach out to people individually so that relationship is between you and the mentor. I'm afraid we can't bring that together. Rohan, question for you. I'm a student in China studying computer science, just joined the IoA. Do you recommend studying in a foreign country like the UK, or is it possible to work remotely from China?
I'd say for study purposes, it doesn't really matter where you are. All of our resources and most resources that you can learn from are available online. Of course, this depends on the jurisdiction of your country. Some resources won't be available where you are, but I know, for example, the IoA resources are available internationally. In terms of working, a lot of companies will allow you to work remotely or work from home. However, you may find restrictions on working from countries outside your own, outside where you live. For example, I don't think I would find many countries in the EU or in Europe that would allow me to work from the UK, just because there is the need for communication and there is the need for stakeholder communication, talking to other people in person, given actual presentations and networking for businesses to evolve. So it really depends on the job market where you are and what your preferences are. But I'd recommend looking to work where you live, generally speaking, but it depends on your situation.
Thank you, Rohan, and
Yeah.
welcome. We're very happy
Yeah.
to have you as a member. We do have another question about do we have specific courses available to support career growth? I mean, the answer is everything we do supports career growth.
Um, we have all of our content, of course, supports career growth in the sense that it is there to support your career professional development in any area that you're interested in. We have a fair few webinars on the topic. We have a lot of our recorded content, and our blogs are more targeted at general career growth, how to progress, and how to have the right mindset to face challenges that you face in the workplace and in the developing kind of landscape.
I would also mention that our tracks and our toolkits are specifically designed to send you in the right direction. If you pick a career within data science, our tracks and toolkits give you a structured career path. We have a question from someone studying an MSc in business analytics in the UK. We're going to keep going and answer these questions. If you're able to stay on, thank you very much. If you're not able, there is a short survey at the end which helps us to choose topics for future webinars. And thank you so much for joining us. For those of you who can stay, we have a couple more questions. So somebody studying business analytics in the UK, what would be the career prospects in this field? Plenty.
Yeah, so business analytics goes kind of hand in hand with business intelligence. There's no problem with the supply of jobs in the job market with business analytics. There's plenty of jobs available. Then there's plenty of routes for business analytics to naturally progress into more technical roles. It's a very solid starting point in the career in the market. It's fairly similar to the data analyst role I discussed earlier. You'll have more expectation of using dashboards and integrating spreadsheets analytics into dashboards. But I mean, the career prospects, especially in the UK, are as big as ever as more companies are integrating data processes into their businesses.
I think that combination of business skills with the data skills is really, really in demand at the moment. Oh, somebody would like to know how you can become a member of the IoA. There's a button on our website. Can we see is our website on your slide, Rohan, there?
Our specific
Yes,
website
it's
isn't.
up there at the top.
Yeah.
Yes,
Oh,
go
okay.
to our website and there's a button there on how to become a member. We're a not-for-profit. A lot of what we do is about promoting the profession and promoting our members, and our fees are not huge. They're very affordable, especially if you're an early career entrant. They're very affordable. We can take you all the way through to professional data science status, which, you know, hands-on evidence that you can do the job, not just that you've studied it, but you can do it. Question here, do you need some experience in coding before you can become a data analyst?
So my answer to this would be yes, you do at least need some experience in coding. There are some positions now that mostly use what we call low code or no code tools and software, which is dashboard software that automatically analyzes data. And those positions will focus more on communicative and data visualization skills. But it's best to understand how the tools you use work. And if you want to have a sense of career progression and opportunity, you will be hindered if you don't have experience in coding. As to become a data scientist or any of the specializations, you absolutely need to have experience in coding in at least Python. If you're interested in becoming a data analyst, I do recommend just dabbling in Python, seeing if you enjoy it. The start of learning a new coding language can be very rewarding. The learning path progresses quite fast, and you do realize that things are fairly doable. It looks a lot more intimidating and difficult than it actually is.
Yeah. Yeah, and I would also say as well, you know, take it step by step. You don't have to jump straight in, and our coding environment is very pleasant. Right, a question here that I can answer. After becoming a member of the IoA, how can we enroll in Data Camp? So if you go to our training section of our member platform, this is if you're a member and you're signed in, if you click on the knowledge and analytics section, then there's all the links are there. And if you have any problems and you're a member, give me a shout or give the team a shout at hello@IoA global.org, and we can sort you out. So it's all in our training content, and you'll see knowledge and analytics is where you learn to do the actual coding, the actual analytics, and then we also expect you to do other things to be a professional data science, like communication, professionalism, those things. How does the membership growth go? Do you need to have some qualifications before you move from one stage to the other? I think I might take this, Rohan, if that's okay.
Sure.
So the answer is you can train entirely with us from zero. Say you work in a warehouse and you would like to understand, logistics analytics. You can start with zero if that's where you are. And we can take you step by step all the way through, and we can get you to the point where you can do some more complex machine learning analytics. If you are very serious, if you would like to go for professional certification status, you are going to need, I'm afraid, a university qualification in this. If you would like to acquire skills that will be useful in the job market, we can help you with those. So it depends on your ambitions and your dreams. If you're in a company, they would like to upskill you, they trust you, they know you, and you plan to stay with that company, then absolutely we can support you with that. If it's important to you to go for the gold standard, which is professional status, you are going to need you're going to need a university qualification. I'm afraid that's just that's a requirement of most professional certifications. And in addition, you're going to have to evidence that you can do the job. A university qualification is not enough. You've got to have that plus years of experience. Question here: what do you recommend to study? What order do you recommend to study in? First data analyst, then engineer, then scientist.
It's
Rohan?
it's not really about, you shouldn't really be thinking about things from a role sense. You shouldn't be thinking about, I'm going to learn to be a data analyst, then an engineer, then a scientist. It's more so, as you study, the natural progression of tools that you will learn will be first best suited to becoming a data analyst. Then you'll learn tools that will naturally be more suited to data science. And then you will choose whether you want to go and learn tools that are more suited to machine learning engineering, or tools that are more suited to any other specialization. But really just start with the fundamentals, start from scratch and learn what interests you. Make sure there's a slide here, you can, in the recording, we can go back to it, that says what I recommend you should have a baseline knowledge of for applying for jobs. But apart from that, you should just learn what interests you and what you're good at. You shouldn't be focusing on the role, you should be focusing on the skills. Absolutely,
yeah. And for your project as well, pick something you're passionate about. Pick a problem you would love to solve. Yeah. And they are very different jobs, very different experience at work. Easy question here. Do you pay does paying membership include access to DataCamp? Yes, it does. Yeah, it's just a one-off membership fee. It's an extremely reasonable offer. We want to encourage as many of you as possible to get into data and coding. So yeah, it's a bargain way to get access to the DataCamp content. Does the IoA provide job opportunities? Not at the moment, we don't have a jobs board, but you can upload your CV and you can do some projects on our DataCamp training section. And that's where, if you're really good, employers will find you. So you can find jobs there, but we don't at the moment have our own jobs board. Will this presentation be shared with you? We record it, and I'm afraid the recordings are always kept on our membership platform. So anybody who is a member can access this at any time, and any of our previous webinars. We have an amazing series of webinars on all sorts of topics that are always relevant, up to the minute, and keep you where you need to be with our industry updates. But I'm afraid those recordings are on our membership site, not on our public site. Right, I think, oh no, is the IoA World recognized for its membership? Yeah, we've got members everywhere. We have you all over the place. We are very privileged to be a global membership body, and we work with. We work on the African continent, definitely. We work with. I'm trying to think. We work in Asia, Africa, Europe, Latin America. We have a couple of links in Latin America. Very strong in India and and that whole region of Sri Lanka, Tibet. We have strong relationships with Tibet. So yes, we're all over the world. And of course, the US, Australia, Canada, the big English-speaking countries. Right, I think the questions are coming to an end, so I'm going to close the webinar in a moment. Thank you so much for joining us. Thank you, Rohan. That was an amazing and really useful talk, really valuable. And we look forward to seeing you in our next webinar. So our next webinar will be on how to evidence the value of data analytics. That will be the topic in May. We hope to see you then. And then we also have a webinar in June where we have an interview with a top cybersecurity expert who will help you understand how to stay up to date with the cybersecurity threat landscape in 2023, 2024, which quite honestly is getting scary. So we hope to see you then. We hope you'll be able to join us then. Thank you very much, and we'd love to hear your feedback at the end of this webinar.